Bioengineered food, also known as genetically modified organisms, GMOs, refers to crops developed through genetic engineering, a sophisticated form of manipulation that permits direct alteration of the organism's genetic material. The technology enables the transfer of desired characteristics into plants more precisely than traditional breeding. This article aims to delve into the history, significance, and health implications of bioengineered food with a balanced evaluation of its benefits and possible disadvantages. Historically, genetic manipulation of crops started as early as the dawn of agriculture, albeit through traditional breeding techniques. Farmers selected crops of interest and bred them for superior attributes. However, the process changed dramatically with the advent of genetic engineering in the 1970s, enabling scientists to insert specific genes into crops. The first GMO, the flavor sour tomato, hit the market in 1994, and since then, the use of bioengineered crops has grown exponentially. The significance of bioengineered food is invaluable in addressing multiple global challenges. First, biotechnological innovation in agriculture aids in combating food insecurity through the production of high-yielding and disease-resistant crops, thereby enhancing food supply. Genetic alteration can also elevate the nutritional content in food, with golden rice, engineered to produce beta-carotene to combat vitamin A deficiency in developing countries, serving as a prime example. Moreover, GMOs can exhibit benefits for farming practices, including reduced pesticide usage, decreased soil erosion and water pollution, and increased profits for farmers. The health implications of bioengineered foods have been a subject of extensive analysis and debate. Significantly, the World Health Organization, the American Medical Association, and other reputable health bodies affirm that GMO foods are no more harmful than their non-GMO counterparts, provided they have passed rigorous pre-market testing. Also, considering the market presence of GMOs for almost 3 decades without documented harmful effects on consumers serves to underline their safety. In the same breath, it's important to notice potential health risks associated with bioengineered foods. Some experts argue that genetic modification can introduce new allergens and toxins into foods, especially through the use of genes from organisms that people are typically allergic to. Overuse of GMO crops resistant to herbicides also spawns superweeds, necessitating more and stronger herbicides, leading to escalated levels of herbicide residue on food supplies, which could pose a health risk. The allergenicity concern, though legitimate, has been factored into the GMO approval process. Rigorous allergenicity assessments are conducted to ensure the safety of the consumers. In terms of the superweed scenario, this is a matter of herbicide use and resistance, rather than an intrinsic issue with genetically modified organisms. Overall, bioengineered food represents a significant development in the history of food production. Boasting the potential to combat food insecurity, improve nutrition, and make agriculture more sustainable, GMOs have the power to address some of the world's most pressing issues. However, as with any technology, it comes with its controversies and potential drawbacks. Higher levels of testing and regulation, stakeholder engagement, and transparency in product labeling can all contribute to ensuring GMO technology is used optimistically and responsibly for our collective benefit. In conclusion, the dialogue on GMOs needs to remain symbiotic, engaging all stakeholders from scientists, consumers, farmers, policymakers, and ethicists. While bioengineered food carries unprecedented potential, their implications, both positive and negative, should continue to be explored, evaluated, and mitigated as we steer the health, ecological, and socioeconomic trajectory for our future generations.